Okay. There's the spooky voice.
Okay, David, it's all yours.
Okay, I'm gonna just put on a little timer. Okay, so the dissertation is titled Disentangling Neural Indices of Implicit versus Explicit Morphosyntax Processing in an Artificial Language. So to start off, I'll just do a very brief overview of the literature review and motivation. Okay, let's center first on this question. Is L2 learning without awareness possible? Two prominent models of second language acquisition say no. Two prominent models say yes. Some very compelling evidence for the yes camp comes from Badrick et al. 2014's experiment, which extends a previous reaction time paradigm from Lung and Williams 2012. Basically, it's a semi-artificial language with the four pseudo words gi, ro, ul, and ne. Participants are told that two of these words go with things that are nearby. Two of these words go with things that are far away. They're not told about a hidden regularity in the experiment, such that two of the words go with living or animate things, and other things go with inanimate or non-living things. Here you can see their trial design. They set up this clever experimental task wherein you can measure learning covertly in the experiment by comparing reaction times to rule violating versus rule adhering trials. And of course, they also took concurrent EEG recordings, which provide a covert measure of neural activity during language processing. There was also a 90-minute nap between experimental blocks, so that they could assess the effects of sleep on learning. So I'm showing here in the bottom right the procedure that they used. Note that the experiment ends with an awareness debriefing interview that allows them to categorize people into rule aware or rule unaware groups. So looking at the results, their behavioral results indicated implicit learning. You can see that here in that the violation trials have slower reaction times than rule adhering trials. And this holds up when you break it down by rule aware versus rule unaware participants. Their ERP results show differences between the unaware and aware learners. So the unaware people had an early negative amplitude deflection. The rule aware participants, by contrast, had a late positive amplitude deflection. So the difference in ERP sort of seems to suggest some validity in the unaware versus aware participants. So Badrick et al. 2014 is the only study to use EEG in combination with this cleverly designed artificial language paradigm to analyze the effects of rule awareness on language processing. And there's been a call in psychology, in the field of EEG research, in second language acquisition for more replication studies. So the first goal of my dissertation was to replicate Badrick et al. 2014 with the following question: can event-related potentials capture differences in learning of a covert morphosyntactic regularity between rule aware and rule unaware learners? Okay, and then moving on to the extension component, we're focused on this broad question: what is the interplay between implicit and explicit processing? So there's different positions about this question in the field of SLA, ranging from the strong to the weak to the no interface position, which have different models of how explicit knowledge or processing interacts with implicit knowledge or processing. However, previous SLA empirical research shows contradictory results on this topic. So Badrick et al. 2014 identify explicitly three open questions regarding this interplay of implicit versus explicit learning. The first one is the fact that the ERP indices of implicit versus explicit processes can't be separately quantified. So in a nutshell, you can't tell if the early negativity and the late positivity actually occurred at the same time in participants, but they sort of cancel each other out, and it just happens to be that the rule unaware group showed negativity and the rule aware group showed positivity. So the question here is whether the two processes are actually covertly or underlying co-occurring. The second one is that rule aware and rule unaware participants might differ in their use of different strategies, like for instance, conscious prediction for a living word when you see the word gi or something like that. So they might differ in the use of predictive processing. And also, we're not sure what exactly the reaction times are showing us in the rule aware learners. That is to say, if they have a slowdown in the reaction times, is it because it's underlyingly the same process as with the rule unaware learners, or does it reflect some different explicit process? So my research questions 2, 3, and 4 look into these open questions like interplay of implicit versus explicit processing. Research question 2 asks if rule aware participants show implicit processing of the rule at a neural level, as revealed by multivariate pattern analyses of EEG data. Research question 3 asks if rule aware and rule unaware participants show neural evidence of semantic prediction from covert morphosyntactic regularity, as revealed by MBPA analyses of EEG data. And if so, do they differ between each other in the use of semantic prediction? And the last question asks, is the P600 component of explicit processing time-locked to rule aware participants' external behavioral responses in an artificial language learning task? Boy, that's a mouthful, but what it means, to put it simply, is it's asking on trials where you have a slow reaction time, you also have a slow ERP response, and on trials where you have a fast reaction time, you also have a fast ERP response, and that lets us see what exactly the ERP response is indexing, whether it's closely tied to the production of the response, or if it's some epiphenomenon that occurs later that's not actually so directly tied to how the reaction is produced. So I'll go over the methods. We followed the same criteria as pattern all 2014. We had in our recruitment criteria, we had 52 native speakers of English. 4 had their data removed for various reasons, so it's just 48. Here's a table with summary statistics about the participant population. I can go back to this later if you'd like. Okay, so our procedure basically follows what pattern 2014 did, except for 4 major changes. Number 1 is the fact that the artificial language pseudo words were shown on a separate screen before the noun instead of on the same screen. This allows us to look at prediction. Next, instead of having a 90-minute nap, they had only a 5-minute break between blocks 1 and blocks 2. So, sorry. And then the third block of trials was added after the rule debriefing interview. The reason we added a third block of trials is because that way, after we tell the participants the rule, we can have both rule-aware and rule-unaware data from the same participants, which allows for within participant comparisons with higher statistical power. Also, our category of living nouns wasn't just non-human animals, as in pattern 2014. We also included words for people like student or professor, so that's also considered a living thing. We needed to do this for 2 reasons. First, we just needed more nouns for accounting for block 3 and for this noun-only block, which I'll talk about in a moment. Secondly, we also wanted to balance animate and inanimate words in terms of factors like concreteness and imageability and so forth. Okay, so with the experiment, the first they do this background questionnaire that assesses their language background, demographic information. Then they do this noun-only block, which I mentioned earlier. Here, participants see nouns in isolation and they say whether it's a living noun or a non-living noun. Nothing to do with the artificial language. The reason we have that is so that we can train this NDPA decoder to tell the difference between living and non-living in the neural activity without confounds from motor activity. Here's a list of some design features we had here that were specifically centered on the idea of making sure that we're really capturing the difference in semantic processing rather than something in the experiment like pressing the left button or pressing the right button. Okay, I can go back to this later if you like. Okay, after that, we introduced the participants, the ULI, RONE words and their near and far meanings, and then we had them do the same forward and backward translation tasks as in pattern colleagues 2014. Okay, here's the screen showing the main experimental task that they did. Like I mentioned before, the pseudo word article and the noun are shown on separate screens instead of together. Okay, and then here's more details about how we're set up. Critically, in every 7 consecutive trials, 1 randomly chosen trial was chosen to violate the hidden rule. And so we can operationalize grammar learning in this paradigm by comparing rule adherent versus rule violating trials. Okay, around halfway through the experiment, they do this debriefing questionnaire. I'm flashing here on the screen the script or the text of the main questions of the questionnaire. We only coded participants as aware if they guessed the correct underlying rule when they were told that there was some kind of underlying pattern of the experiment. This relaxes the criteria used in pattern all 2014 a little bit because we didn't require the participant to explicitly say that they noticed the regularity during the main task. As long as they guessed it correctly when we did the interview, then we considered them more aware. Okay, under this scheme, we had 24 participants coded as aware and 24 coded as unaware. All right, so going over the analysis and results, I'm going to show the analysis and results for each research question sort of together because that makes it flow a lot better. To begin with, we did this behavioral analysis to see whether or not there was a learning effect, all things being equal. We did this just like David all did, looking at ANOVAs on reaction times and accuracies. So looking at all participants, we found a learning effect in that whenever a trial violated the hidden rule, there was a slower response. And when you break the data down into rule aware versus rule unaware participants, they both show that learning effect. So in the ANOVAs, we had a significant main effective condition, i.e. they slowed down whenever there was a trial that violated the hidden rule. And there was also a significant effect of epoch in the ANOVA, such that they got faster over the course of the experiment, but there was no significant main effect or interaction from rule awareness. Okay, when we look instead at the accuracy results, the same storyline comes through. Here they have lower accuracies for rule violating trials. It holds up in both the aware and the unaware participants. And we had a significant main effective condition, but again, no main effect or interaction from rule awareness. So those are just the behavioral results. Up to now, we're pretty good. We can see that the that the experiment is producing some learning effect, and actually, just like in Pattern et al. 2014, it's equivalent between the rule aware and the rule unaware participants. Moving on to the ERP replication analysis. This screen here has some details about how these were actually conducted, which I can go back to if you like. The only significant ERP effect that we found was the late positivity in the rule unaware participants block 2 data, which I've highlighted here. You can see the difference in the waveforms and the scout map in the late time window. Okay. However, after they did the rule debriefing interview and we told them the rule, the effect seems to go away. And also for rule aware participants, we didn't find any significant ERPs. Okay, so this doesn't seem to reproduce Pattern's results. For research question 2, just a brief reminder, what we wanted to do was see if the early negative and late positive ERPs are underlyingly occurring at the same time using time generalized multivariate pattern analysis, which is kind of conceptually shown here. Okay, what we did specifically was first we trained an MBPA decoder to detect EEG indices of implicit processing. We took the rule unaware participants block 2 data. This is the point in the experiment where their behavioral effects show some learning, but their interview responses show that they're not yet consciously aware of the rule. Okay, so we took this decoder that we tested, that we trained, and then we tested it on their own block 3 data after we had told them the rule. And if we get above chance trial classification accuracy with this analysis, it would indicate that neural activity related to the rule during block 2 is also occurring after the rule aware in block 3. Okay, so let me show you the results of what we did. We didn't find any significant decoding here. It was not the case that implicit processing seemed to occur with periods of rule awareness. So here in the bottom left, we have the diagonal decoding results, which show for each millisecond time point in the training data, its corresponding performance when tested on the corresponding period in the testing data. So for instance, 500 milliseconds versus 500 milliseconds, 501 versus 501, et cetera, right? So here you can see that the performance is just hugging chance throughout, even though there's some periods where it's a little bit above chance level after you do correction for multiple comparisons, which I'd love to talk to you about afterwards. We do not get significant results. Okay, and this is shown that the vector is not like highlighted and bolded. Okay, when we look at a time window generalized approach, what we did was we trained the MVP decoder only on the time window from the ERP epoch in which the significant ERP effect was found, and then we tested the decoder's performance. And here again, it's at chance level, in fact, in the universe. Here on the bottom right, you can see the temporal generalization matrix, which tests each training time point against every other time point. So for instance, maybe your neural activity at 200 milliseconds predicts what happens at 500 or 600 or stuff like that. Even though these little red splotches show above chance performance, it's not significantly so when you correct for multiple comparisons. Okay, so there's no results. Semantic prediction analysis for research question 3. This is kind of the same approach conceptually. What we do instead though is we train the MVPA decoder to tell apart the difference between reading out living versus non-living noun, and then we test the same decoder, but specifically on the part of the experiments where they see only the artificial language pseudo word, like gi, ro, u, ne. And so if you do it that way, if you get significant above chance trial classification accuracy, then it can show you that you're kind of like activating the concept of living or non-living when you see the article in isolation. What do we get here? We did not find significantly above chance decoding accuracy. So neither for the rule aware participants nor for the rule unaware participants do we get significant results either in diagonal decoding or in the temporal generalization matrices. Even though this looks very red, the fact that it's not highlighted and bolded and so forth shows that it's not above chance when you correct for multiple comparisons. So we don't find signs of prediction in either group. Okay, and now research question 4 does something a little bit different. Basically, we're trying to see the relationship between the ERPs and the reaction time. So on trials where you're slower, you have a slower ERP and so forth. We did the same 4 analyses as Sassenhagen and colleagues 2014, such as visualization with ERP images as is illustrated here. Let me break this down for a little bit more. So here to begin with, we performed this analysis on the rule unaware participants block 2 data. This is the only block of the experiment where we got a significant ERP effect. We would have really liked to have done it on the rule aware participants, and then we can make more specific claims about consciousness and explicit processing. But we're working with what we have with the result that was significant, and we can at least still see what how the neural indices are related to behavioral performance. So when we look at the ERP images, it would suggest a time locking effect that was a little bit weak. So these are ERP images. What you do is you take all of the trials of the experiment and you color code them such that blue means a negative deflection and red means a positive deflection when you subtract them from the mean control condition. And then you can stack these up and order them based on the response time. Now, the response time here is shown with this sort of curvy line. And the idea is that if you get some splotch of color that sort of follows this line indicating the reaction times, then it will sort of show that the ERP occurs at a given point after the reaction, whether it's a slow reaction time or a fast reaction. So here, the fact that there's kind of a parallel red line, even though it's rather faint, and notice that these colors have been kind of smeared for visualization purposes, which I described a bit. If you replot the data here, such that the response is on this vertical line, and you just shift the trials no matter when the actual noun was shown, so that the response is always on the same vertical line. Notice how this red column, doesn't vary in the timing. It always occurs at a very consistent point after the response. So that suggests some visual evidence of time logging. Of course, this is only kind of a subjective visual reading of the plot. We turn to our 3 statistical tests. When we do the reaction time quartile ranked approach, which I can describe later, we get a significant effect. The other 2 statistical analyses that we did following Sassenhagen and colleagues trended in the same direction, but were not statistically significant. So we attribute this to the rather weak nature of the ERP that we found in our data. So moving on to the discussion. Overall, our behavioral results show learning in both the aware and the unaware groups, and the breakdown of 24 aware versus 24 unaware participants roughly follows what previous folks have found. They'll note that we used rather relaxed criteria. When we look at RQ1, we showed some differences between the aware and the unaware learners, in that only the unaware learners showed this positivity. The rule aware learners didn't show anything, but this doesn't reproduce bad mixed results of a negativity for the unaware learners and positivity for the aware learners. In the dissertation, I attribute this to possible natural variability in ERP's tied to grammar processing, as shown by Tanya in 2019 in this high-powered study. So to visualize this, what I'm showing here is the data from my participants in block 2, and you can see here on the x-axis their ERP effect in the early time window, on the y-axis the ERP effect at the late time window, and it's color-coded by whether they're aware or unaware. So basically, the fact that these folks fall along this spectrum with no systematicity to it suggests that grammar processing ERPs are variable, as Tanya found. And it suggests in turn that group average ERPs may not be ultimately informative for our research question, because whether or not you get a significant ERP in the group-based analysis just reflects whether more of the dots happen to be in the top right corner and the bottom left corner. Okay. Okay, thank you. Yes, RQ2. So we showed no evidence for implicit processing or aware or unaware processing. However, some follow-up analyses that we did within block decoding, where we trained and tested the decoder on the same data using 5-fold cross-validation, shows that our decoder wasn't really sensitive in the first place. This was the same even when we tried different decoding approaches that control for a host of variables in the experiment. By contrast, when we run the same analysis approach on native English reading, then it shows really robust effects. So it seems to me that that pattern just isn't in the data rather than something about our approach. For RQ3, we found no evidence of semantic variation between aware or unaware participants. However, again, our decoder within block analyses doesn't show statistically significant performance here. So here for the aware and the unaware participants, you can see how good their decoders were at telling the difference between living and non-living in the non-living block in the first place. And for neither case was it statistically significant. I attribute this in the dissertation to trial-to-trial variability in the data that we used to test it. And I have a whole storyline that I'd love to share with you afterwards for question and answer. And I say, as I say in the dissertation note, it's better to have valid null results than invalid significant results. So for instance, in my dissertation proposal defense, I showed some decoding from bad rates data that when you look back at it, could have just been the difference between left versus right button press, rather than the difference between living and non-living. Okay, so RQ4, we found evidence for time locking from our analyses. However, some of them were only just trending and not significant, which I attribute to weakness of the ERPs. So actually, here's the same ERP image from my study that I just showed you. When I perform the same analysis on bad impedance data, you can see that these red splotches are much more prominent in her data. Maybe because they got a 90-minute, nap, they were less tired. The ERP effects were stronger. So it doesn't actually tell us anything about explicit processing specifically, but it suggests that the ERPs are at least closely tied to behavioral responses. Or it could show that the explicit processing that they did was about a button compound in the experiment, which I'd like to describe in just a moment. So up to now, what we've seen is that the behavioral effects were strong, but the EEG effects were not very robust. And I argue in the dissertation that this could be due to low-level non-linguistic domain general learning in the experiment. So when you look at the trial design, you can predict whether you're going to press the left or the right button based on the Guy-Roux-Oulnay article in isolation. There's this stimulus response contingency. So it's possible that folks are associating Guy and Oul with the left button press and Ronet with the right button press rather than anything about the semantics. So the dissertation presents a whole host of other analyses viewing this data from different angles that suggest that there's some kind of domain general learning effect involved. Now, the dissertation also talks about why it is the case that there was at least some linguistic learning going on, which I'd love to go into some details too. But ultimately, we conclude that there's some linguistic learning, but also some non-linguistic learning involved. Okay, we compare results to Benefit 2014. We behaviorally replicated their results pretty much, but there was a stark disparity in ERP results, which we attribute to natural variability in grammar processing ERPs or to differences in the design is noted there. Nevertheless, it's notable that we still found evidence for rule and aware learning, even if this could have been boosted by low-level motor response time. So speaking of the interplay of implicit and explicit processing, the fact that we had similar behavioral performance between the aware and the unaware groups would seem to be evidence towards the no interface models and away from strong interface models. We didn't find MBPA evidence for co-occurrence of implicit processing through rule awareness, but again, note what we said about limited decoding sensibility, which means that we might want to be very tempered in our interpretation. Okay, there's two findings I want to highlight here that are relevant for future artificial language studies. First is that we need to be very careful when we design these trials to make sure that the learning is linguistic rather than boosted possibly by some motor sequences. And this critique also holds for prior studies that have used this design, because even though it might not have been as strong because they showed the noun and the article in the same word, they still have the fact that whenever you saw Guy or Oul on the screen, it was one button press versus the other. So which button they're pressing versus whether it's really living and non-living that they're thinking about is worth thinking about. Also, some piloting data suggests that not all participants use explicit knowledge the same way. So for instance, when they are just exposed to the rule animating and pick it up on their own, they kind of like over-apply the rule and then under-apply it later, versus when you tell them the rule from the beginning, their behavior is different. So we might also want to think about the like meta-linguistic ideas about whether or not the grammar rule is worth following given the experimental context. In the dissertation, I go into some limitations of the dissertation about generalizing these findings from the very specific and idiosyncratic study to other groups. And also at the end, we just wanted by saying, one, that it's important to replicate prior studies, two, that it's important to use a wide toolbox of analysis, and three, also that understanding implicit and explicit better can have some tangible ways or results or interpretations for how English should be taught. So thank you to everybody who was involved in the project. Thank you also to the committee.
I'm a New Yorker and I'm impressed with how fast and clear you did that.
Great. Yeah, very comprehensive and concise overview of the dissertation. Okay, so now we will move on to the question and answer phase. We normally give our external committee members the chance to go first. This is partly because they used to be on Zoom and everybody else was in person. We didn't want to work on Skype and we didn't want them to be disconnected, but we'll still go with this tradition that we have now. So either Laura or Philip, if you would like to start with questions. We have about 10-15 minutes for questions for everybody, but like I said, it can become more of a discussion.
I'm happy to go in either order, but if you have a preference, doesn't matter.
No, you can go first, it's fine. Yeah.
Okay, so hi David. Thanks for the really clear presentation, and I really enjoyed reading your thesis as well. It was really well written and nice to read. And
Stop sharing your screen. Sorry, maybe stop sharing.
There we go. Hi, now we
And then you can share it again if you need it. Okay.
oh, I'm like really on the big screen. Okay, I can kind of.
Yes.
You make me smaller. No, it's like
you're in the room with us, really.
Yeah, it does.
Okay, so yeah, I was gonna kind of dive into some of the EEG analyses that you did, and try to get a little bit better of an understanding, maybe of the data that you presented as well. So the analysis that I guess, research question 2 and 3 are focused on. I think it was a potentially really interesting way to kind of get at some of the questions you're interested in, to do this sort of multivariate pattern analysis. And unfortunately, it seems like it just didn't quite pan out in terms of giving you being able to conclude much, I guess, just because some of the results are pretty much not showing that the classifier could pick up on anything. So I'm just wondering if you can kind of explain a little bit more about why you think maybe the decoder performed so poorly. And in particular, I think you have an analysis that's laid out in your supplementary section or your appendix, where you show that even when you try to train the classifier within blocks, so within the noun block and within block 2 and 3, I believe, you're still not getting above chance classification accuracy. So yeah, just if you can elaborate a little on why you think the classifier, I mean, at that point, I guess when you do the within block classification test and you're not getting above chance accuracy, it almost seems like there's no reason to then even be able to test your main question, because it's like, well, of course, if it's not going to be above chance even within block,
Right.
like it would be almost a miracle, or it would be kind of
Right.
surprising if it did anything when you're trying to generalize it past that. So yeah, I'd just like to hear your thoughts on that.
So I've got several points that I'd like to touch on. So the first thing is that whenever we're working with an artificial language learning paradigm, we should kind of know that our signal to noise ratio is going to be severely limited by the fact that participants aren't just showing whatever effect we're after from the very first few trials. Like by design, you need some time in the experiment before the learning can really occur. So even though we're looking at block 2 after they've already had a whole block of trials, it's not necessarily, we can't take for granted that every single trial and all the participants' block 2 data was actually showing the same learning effect or even the same kind of learning effect, because it's an artificial language. Of course, one of the strengths of this paradigm is that it can covertly test learning as it happens. But what it means is that for 300 or so trials, the participants are shown to, in a sense, conceptually, only a few of them might show the real beautiful learning effect that participants have applied to rule to a degree. A second one too is a little bit about how the sausage is made, so to speak, in the MBPA analysis. One important thing when we train the classifiers is to make sure that we have an equal balance between the two conditions that are being compared, I guess. So for example, if we're teaching the classifier to tell the difference between the rule adhering and a rule violating trial, then it's very important that we use the same number of trials to represent the rule adhering condition and the rule violating condition. Now, one aspect of the design is that one aspect of the experiment is 1/7 of the trials are violation trials. And then that means that you can only use another 1/7 of the total trials you have to match 1/7 of the data for the rule adhering trials and 1/7 of the data for the violation trials, which reduces your sample size significantly. So this kind of technical point in a nutshell means that say like 300 total trials in the experiment, the analysis is really done on 2/7 worth of that data. So that also kind of hurts as well. And then the third thing that I like to notice too is that you might recall around 3 years ago on that lovely day in June, we had the defense proposal practice that was in 17th floor instead of the 15th floor. But at that time, I showed some MBPA decoding results for your data from 2014. And what we found there was that even in cases where there was a significant effect or decoding effect being shown, the signal to noise ratios or the nature of the decoding was always not a very clear effect. So for instance, in cases from your data where we had a significant decoding, it was always around 55 or 58 or something like that. So that's not in any way critique of your data per se, but just to say that in this kind of analysis, all things being equal, the kinds of effects that we're looking for are rather subtle. So those are sort of 3 factors that can affect sort of your ratio of signal to noise that can be picked up on. The other thing too that I should mention is that in the dissertation in Appendix E, I think it was, I have pages and pages where I go on showing different results from different MBPA analyses that try to control for different things. But one should bear in mind when looking at those, that a lot of those controls are also in turn limiting the amount of data that we have to train the decoder. So for example, one of the analyses that I did said, okay, it's not only just the case that you're going to have the same number of rule adhering and rule violating trials when you test the MBPA decoder. The additional thing that we'll try out, for instance, in one analysis is we'll make sure that you have the same number of GI, RO, UL, and NA trials within the rule adhering and rule violating conditions. So to put it simply, you don't want it to be the case that the decoder thinks that a trial is rule adhering simply because it was tested on data that happen to have a high percentage of GI trials. Like when you train the decoder, you happen to have more GI trials than RO trials. And so the decoder doesn't learn to tell the difference between rule adhering and rule violating. It underlyingly starts to just become a detector for when the brain sees GI versus the other words. So in one of the follow-up analyses, I try to control for some of those compounding effects by saying, okay, now GI, RO, UL, and NA have to be equally represented when you train the decoder. But that means trimming down the number of trials you have. So for example, if you have 5 GI, 6 UL, 7 RO, and 8, whatever the last one is, trials, you can only really use 5 of each of those trials to keep the categories balanced. So that's just one example for the follow-up analysis of how those controls limit your sample size even further. Another approach that I took was to decode only rule adhering versus rule violating for the left button presses, or rule adhering versus rule violating for the right button presses. Thinking to myself, maybe some kind of like a motor response effect leaks in or something like that. So maybe doing that control could be helpful so that we make sure that we're not inadvertently comparing, or to see whether the left-right difference might be getting in the way. But when we do the sort of follow-up analysis within a button press that tries to like pull apart or scrape off as cleanly as possible any possible compound from the left to right side, then that reduces the trials even further because now you can only use the left trials. So I think it's tricky to use decoding with these artificial language learning paradigms where from the beginning you know that the effect is going to be sort of limited. By contrast, one thing that I admire about Kara's Brocanto studies, which Alexis, who's in the room, and Marina, who's on Zoom, have been working on with Brocanto, is that it's like 4 sessions with a live person instead of all computerized. And so you're like investing the time and making sure that the participant gets like a lot of exposure so that the learning effect can be very robust rather than this very transient kind of thing where you only get it for a few trials. Another thing that I should mention too, in terms of the limit of the number of trials on the learning that can happen, is that one of the follow-up analyses looked at the effect of the running proportion of rule adhering versus rule violating trials for each of the pseudo words over the course of the experiment. So for example, to put it simply, GI is seen several times in the experiment, but at certain times in the experiment, you just happen to see it in a rule violating condition relatively more or less compared to the other pseudo words. So that means that participants have this running statistic of contingencies with the button press that they learn for each of E, RO, UL, and NA. And the fact that we found a significant effect for that running proportion of trials for each of those pseudo words would sort of indicate that that you're very limited in the kind of learning that occurs based on the few trials that you have seen. That makes sense. So I think folks who are working with an artificial language, you know, when you're looking at the theory behind the methodology, like I did in the dissertation proposal, I say, oh, these artificial languages are great. You're controlling for so much stuff. It's like a little laboratory of how learning happens, how can you go wrong? But then the flip side to it is that it takes a lot of sort of investment to make sure that participants really sort of learn it in a way that creates a very strong signal. The other thing that I like to point out too, that was kind of snuck into the design after the project was proposed, is that to have clean and what's the word, confound-free decoding of living, non-living, we also needed to have that early task. We have that early task where they tell the difference between living and non-living in the noun-only block, and that also further extended the amount of time that the participants were in the EEG booth for this long experiment, which also means that fatigue might have contributed more. Like, it's not just the fact that they didn't have a 90-minute nap, it's also the fact that they had done like an extra task beforehand. So it means that when they're finishing up the task in block 2 and block 3, some of them, they've been in the booth for like 2.5 hours, and it can also lead to further reduction in data quality. So for example, actually, if you look at the number of artifact-free trials that we had in the experiment, it's kind of a shame, but as the experiment goes on, participant gets more tired, they wiggle around, it throws out the EEG data, you can see how the number of trials continually goes down. So actually, block 3 has fewer trials than block 2, block 2 has fewer trials than block 1, and so forth. So those are all things that can kind of reduce your signal to noise ratio or your ability to pull out these significant effects with MVPA. There's another thing that I'd like to.
Let's just so that we can make sure we have time
No
for
problem.
everybody to ask questions, like, obviously, I think we're all gonna see that we will have several responses and have thought very deeply about many of these questions. If you could kind of focus maybe on the top two most
Oh, yes.
important, and then if the committee members wanna dig in more, they can dig
Gotcha.
in more, and that way we can get to all the questions. Yeah, Laura.
Okay, great. So it sounds then like, to summarize what you're saying, decoding is maybe a better approach when you have a very robust neural signature that you can pull out. So I guess if you were able to go back into a time machine, go back 3 years, are there certain things that you'd change? Would you still use decoding to investigate this question? Would you change the paradigm in a certain way? Or what, if you could go into a time machine, how would you change things maybe?
I think, let's see, I think one thing that might have changed would be to try to make sure that the participants dive into the task as soon as the experiment begins. So you can think about doing like a 2-session study. That's one possibility. I can also, if I can use my time machine to go forward in the future, another thing that I would point out is that one sort of decoding analysis that I haven't tried is aggregating the data across all participants and seeing if we get better luck that way. But in terms of how I would have done the paradigm different, I think maybe having a second session and collecting more data in which each point in the experiment would have been less subject to fatigue in the way that we had set it up. The other thing to be said too is with the piloting that we had seen, we had sort of known ahead of time, or we could see ahead of time that it would be tricky for us to tackle the difference between non-linguistic and linguistic learning in the experiment. But our piloting indicated that the only way we could get the learning effect was by using the trial design that we did. So what I mean to say is I kind of went into it also knowing that the sort of linguistic effect involved might be reduced by the fact that there was this tricky issue with the button presses.
So yeah, that brings up another question I was going to ask you about. So you replicated our finding of the response time effect, but not really the ERP effect. And the main explanation that you give in the dissertation has to do with the variability across individual participants and how that may lead to non-significant group level effects. So I see that point, but I also wonder to what extent, so then why did we find those effects, given that presumably we also have, human participants that should show similar levels of variability. We also found the P600 type effect in rule aware, which is sort of consistent with this idea that P600 is a marker of conscious syntactic processing. We find this negativity, which has been reported before as kind of an implicit marker. So all of those things do sort of converge with prior research, both in the linguistic and non-linguistic areas. So I guess, yeah, to what extent do you think, was there something about your participants that maybe made them more variable? Was it really due to the level of fatigue? Could it have been due to this 90-minute nap that maybe consolidates and helps produce larger, more robust neural effects? Yeah, just I guess the idea that there's variability. I guess you have to go one step further and say, okay, then why did that happen in your study and not kind of the previous study?
Yes, there's several thoughts that come to mind. So first off, you mentioned some of the obvious things like the fact that they didn't have a nap. I mentioned before how they had the non-only block, so the participants were maybe a little bit more tired. But what I like to point out is that these aspects that affect variability in the data that I see, there's a specific reason why the variability that you could see trial to trial could indeed would be especially pernicious for detecting ERPs. So for instance, in one of the other Tanner publications that I cited, they talked about navigating the difference or navigating the fact that an N400 and a P600 can sort of both be shown in the same trial, or the fact that this spectrum exists. And they talk about how differences in tasks can have different effects on the latencies of the N400 versus the P600, such that little manipulations they do in the experiment that introduce variability could smear the data even further, not just because of a single ERP component, but of the fact that there's two of them involved at the same time, whose timings may sort of vary given certain things about the task. For example, let me illustrate that for you. One kind of difference that in retrospect seems like it was just very glossed over in the proposal defense is the fact that they see Guy or Rowe, they see the artificial language article for about 350 milliseconds, and only afterwards do they see the map. Like, we stagger the presentation. But that difference in how and how the words are shown, or the fact that it's shown a little bit before, can have a really big sort of cascading effect on the variability of possible conscious or unconscious processing that can happen afterwards. Like, if what I'm saying is, if participants get this little time to make a prediction or something like that, then you might see more variability to the data, in the data, to the extent that the participants that make the prediction quickly versus the ones that make it slowly would have corresponding more skewed sort of neural effects. By contrast, when you show Guy horse, nay rabbit, etc., like on the same screen, then that is also something that might limit or reduce the variability in your data to the extent that it's really just seeing how participants respond at one point when they see the couplet, right, Guy horse, but not sort of starting two possible processes. Like, for instance, the participants see the pseudo-word article before, and then you see the noun afterwards, then here you have sort of these two ways that they can vary a lot between each other and the kind of processing that goes on. Yes, and talking also about the variability, just an intuitive take is that I think that the reason that we found a P600 specifically for the rule unaware participants is because maybe if they thought less about the word that was involved, then there would have been more variability sort of trial to trial and cognitive processes that happen. So one thing that I wanted to point out before with the ERP image picture is that actually if you compare my ERP images to the ones I generated from your data for 2014, the lag between the reaction time and the positive amplitude is much shorter in my participants than the lag between the reaction time and the amplitude in your 2014 data. So this sort of makes me think, well, maybe if the P600 is capturing some kind of explicit effects, if like what I'm saying is mine could be capturing some kind of surprisal effect too, but if the nature of the surprisal effect is this very sort of low level domain general surprise and not pressing the button that you were expecting, rather than thinking, well, living and non-living conceptually, that can also, or that would show potentially how the nature of the conscious processing would be different between participants. One little more thing, I see Kara's looking at me. One little more thing that I want to say is that the fact that we diluted the differences between living and non-living things by keeping concreteness and valence and arousal matched between the two is actually more significant than it might seem at first. For example, because if my words for living things were all kind of vague and abstract things like professor, student, protester, that don't have the same kind of tangible and visceral kind of living quality as snake and frog and toad and so forth, like the fact that we matched all those factors might have been that we eliminated or we reduced the differences that we could have found for the semantic decoding because we use these words that are specifically very sort of abstract in their meaning. So that's another possible source of variability. I don't know if that makes sense. Actually, one quick anecdote is that Gina Cooperberg, who had done decoding-based analysis of living, non-living, and prediction and stuff like that, we had some email exchange back and forth, and I was really asking her, oh, gosh, if we match living and non-living for all these articles, then does it mean that we're like throwing out the things that kind of make them different in the way that they're processing? Because I've been looking to control them for so many different variables. Variables, in fact, that you had mentioned about 3 years ago on that fine day in June, related to the fact that the living words in your stimuli were more concrete and so forth than the non-living words. And actually, there's a sense in which, for telling apart the difference between living and non-living, that decoding specifically might have been actually limited by the fact that we use very non-living living words and possibly also very living non-living words.
Yeah, that does help to sort of further explain why the variability may have interacted with some of these experimental differences that you use in your design. Kara, how am I doing for time? Am I out of time?
Maybe one, if you have one question, or we can come back if we have time, and we'll just try and have more concise answers. Sorry.
Yeah, I have another question. I'm happy to ask it now, or
yeah, go ahead, Laura.
Okay, so you mentioned both in the dissertation, also the previous response that you gave to one of my questions, you did this kind of like running tally analysis where you would compute basically the local probability that a violation of a particular article had just occurred. And you said that because that sort of local probability predicts the violation effect, you presented that as evidence that this was kind of a non-linguistic violation processing or a non-linguistic type of learning. And yeah, I just wanted to kind of probe you a little bit on the logic behind that, because to me, that doesn't necessarily seem like a clear rationale for why that would be non-linguistic. So if you think about like statistical learning generally as it applies to both linguistic and non-linguistic kind of domains, we think of sort of that also as being kind of the accrual of probabilities within kind of a language context, if we're talking about like within the domain of language. So I guess I don't necessarily see that as the logical outcome of that analysis. I think the analysis itself is really interesting, but I could also see that being compatible with a linguistic explanation where GI is more strongly associated with, say, living things, because you haven't had a violation in a while. So then when you do get a violation, it's extra surprising or extra difficult to integrate. So yeah, just wanted to hear your comments on that.
Yes, so my intuition there was that in linguistic knowledge, especially explicit linguistic knowledge or conscious knowledge, there's the sense in which you could conceptualize the rule as sort of more categorical thing. Like all living things would go with, or GI would go living things like all the time, like categorically, and the other one not so much. Now you mentioned that natural language, so seeing from that I won't go into that one. It's like I'll go straight to the second point. The other thing that I wanted to mention too is that a lot of systematicity in language, like the fact that that patterns aren't and rules aren't 100%, that kind of systematicity or the exceptions themselves can have some systematicity to them, in that categories of certain words might be excluded or included. So for instance, thinking about how like prepositions are used, that in some cases, a grammatical pattern isn't just entirely like random in terms of when it does and doesn't apply in natural language, but a lot of those exceptions might have some clustering within them. By contrast, so the reason what I'm trying to get at is that in my experiment, there was no kind of systematicity at all in how the violations, or in which words a violation could occur with. So I guess what I'm trying to say is that if what would make it more comparable to the violations in a natural language is if there was at least some underlying systematicity, to extent that exceptions aren't always random, when exceptions to pattern occur in natural language. But looking back on it too in the dissertation, when I wrote that, I think I might say that at the very least what it shows under the least generous interpretation of the data from the running time window analysis is that that effect that's being captured is not, it shows that it wasn't so much conscious explicit processing that drove rule performance untainted by co-occurring implicit processing or motor response prediction. Does that help? Or I feel like I went on too much.
Yes, I think that I would agree more with that explanation, that that's evidence that it's not entirely driven by explicit categorical knowledge, but I wouldn't necessarily agree with the fact that that's driven by motor response. I think it could be driven by a conceptual sort of probabilistic, linguistic, statistical framework that's not a motor-driven response necessarily. Now, it could be motor-driven, but I don't think that piece of evidence in and of itself indicates that it's entirely motor-driven. Yeah, I'm probably out of time here, so I'm happy to let the next person go.
Thank you, great, Laura, for those questions. Yeah, great questions. Philip.
All right, so thank you, David, David, and thank you for your really super researched and very thoughtful approach to everything in the dissertation. Fortunately, a lot of my questions have either already been asked by Laura or you answered them in chapter 5. Which is really nice. As I was going through chapter 5, I had tons of questions. What about this? What about this? How dare you say this? All those kinds of things. And you answered the vast majority of them. So that's really cool. That said, I still have a couple brief thoughts. I certainly, where do I want to start? I'm going to go here. In your behavioral results, especially the reaction time results, I didn't see, I'll put it that way, I didn't see a significant condition by epoch interaction effect, but you subsequently ran t-tests on that anyways. So I was wondering why you did that. And if there's not a significant interaction between those two, doesn't it imply that there was just no learning before the block 3, before the rule reveal?
You mind, I think I'm gonna screen share the PowerPoint again, just because I wanted to make some notes about how the notice performed and why that might be relevant for the interaction. Bear with me while I fumble with Zoom just a little bit. So one thing that I wanted to mention is there's a lot of different ways to do the behavioral analysis. What I opted for here was to follow what Badrick and colleagues did as closely as possible. What I mean to say with that is that I think, if I'm not mistaken, the ANOVAs and t-tests that are reported as the quote unquote main behavioral analysis are for blocks 1 and 2. So we do one ANOVA with 8 epochs. And then I also presented a different ANOVA just on these 4 epochs at the end. And my idea with doing so was that first we have one that replicates as closely as possible Badrick and colleagues' approach to the analysis. And then the separate one just on the block that I ran. But note that this affects, or note that the reason that this is important is that this can dilute the nature of the interaction if you're only looking at some epochs, but not others. Now, you mentioned that I presented the t-tests from a follow-up analysis that technically wouldn't have been warranted by significant interaction. I think maybe at the time, my thinking was it's a dissertation, everybody in the committee is forced to read it. I'll be like as thorough as possible so that nobody can fault me later for not having shown it, or if somebody's curious about seeing what the results might have been. I think another approach, which would show good statistical discipline, would be to say, no, I'm never going to peek under the lid unless the little star indicating P lower than 0.05 warrants it. I'm not sure if that captured your question, but I wonder if okay.
Yeah, that answers my question. It was one of those things where the stats didn't shake out with my initial.
Yes.
That's not true. The stats kind of fit my initial gut response, which is it looks like there's more learning in the rule aware group by the time you get to epochs 7 and 8. Very little overlap between those error bars, whereas in the rule unaware group, those error bars are still heavily overlapping. And so I expected there to be some sort of interaction. There wasn't at that point. And then you went and did the analysis, that t-test, which you're right, I would have wanted to see that because it looked to me like there was learning that actually looked different between the groups. So I was kind of with you and not with you at the same time all the way through those analyses as far as those kinds of things go. Relatedly to that, you mentioned earlier in your answer to Laura that I think it was with respect to the ERPs, since you have 1 in 7 trials that were rule violating, that you then looked at also 1 in 7 that were rule adhering. Is that what you had said?
To be honest, I think that this analysis just used all of the rule adhering trials versus rule violating trials. I will say though, that's shame on me though, because I'll be violating the rule that Steve Luck gives in his handbook for ERP analysis, saying that you shouldn't compare conditions when you have different sample sizes. So for instance, here, what's not shown here, or what I should point out, or if I were to show error bars here, the error bar for the red lines would consistently be wider than the error bars for the black lines because there's more trials for the black lines that are shown there.
So that same thing then applies to the reaction time analyses, correct?
No, in the reaction time analyses, I believe following the same thing in that I didn't whittle down the sample size for the rule adhering trials to match. I will say one thing about the reaction time analysis though. There is one kind of issue with using the median reaction times to find these differences in data that are skewed like this.
Sure.
And there was actually we did a poster at APS about that when the data are skewed, then the medians are affected differently when you have differences in sample sizes. We ran some follow-up bootstrapping analyses that aren't even talked about or touched on at all in the dissertation to show that the effect is robust even when sample sizes differ in the reaction time analysis.
Sure. No, that makes sense, and I appreciate your candor about that. But I was actually just thinking, I wonder if that's why some of the results weren't significant. It's just because you have fewer. Some of those interaction effects, if they weren't necessarily significant, just because the amount of variance is different between those rule adhering and rule violating trials by the very fact that there are fewer rule violating trials. And so basically the point of that is to say, don't despair. There might be more learning there than is even being shown, just because this is another source of noise, right? You were talking about signal to noise ratio earlier. This is another, source of that noise. So.
Can I just one very nice way to visualize how you can pull out trials that do versus don't show an effect is by looking at the ERP images. So, for example, just conceptually, I pointed out in the dissertation that this sort of very weak parallelism between the reaction times and ERPs seems to be more prominent for the trials that have faster reaction time, showing that, for example, what I'm getting at is that there are some trials that were quote unquote good trials, and that the participant was attentive and did what they were supposed to and answered quickly, and those trials also showed the neural effect correspondingly. However, when you have trials that have a lower reaction time, it's possible that all sorts of things could have gone into why the response was delayed, which makes it less likely that you pull apart some like neural sort of activity. There's some Gaussian filter that goes on here to make it easier to see the swatches. But keep in mind, these little red dots, they're actually more like islands, because there's trials that, even though they have a faster reaction time, don't show strong ERP effect at all. But one possible avenue to go into it could be to do visual inspection of the ERP images to say, okay, which trials or what kind of activity are we looking at that best represents the learning effect graph. One thing I want to point out too is that we only looked at correctly responsive trials in our data. I think Badger colleagues 2014, they present at least one analysis where they also include ERPs to incorrect our responses, but I might have to look at it more carefully.
Right.
So that also makes a difference whether you only look at correctly responded versus.
Got it.
And there's arguments for both.
Got it. Thank you. Kara, do I have time for one comment and a very short question, and then I can back off?
Sure, that sounds perfect.
Okay. So I'll throw the comment at you as something that I want you to think about going forward, rather than something that's a criticism of the current, document or your dissertation. You talk a lot in your dissertation about the issue of the implicit-explicit interface, and you sort of are working between three sort of options: the strong, the weak, and the no. One thing that is omitted, I guess, I'm not sure if it's omitted or if it's technically not an interface position, but it's a variation, and I don't know if it's no interface or strong interface. But what if, how do I want to say it? Another possibility is that the implicit and the explicit knowledge that is acquired in this kind of study are entirely isomorphic. It's one underlying source of knowledge, and it may or may not rise to conscious awareness. And the reason I bring that up is because recently there's been sort of a resurgence in instance-based approaches to learning and memory. And in instance-based approaches, you essentially have one memory repository full of memories that are maybe going to rise to conscious awareness and may not rise to conscious awareness. And a lot of these, on these sort of approaches, the idea here is that learning isn't necessarily implicit or explicit, because that implies that the learning mechanism is looking for certain kinds of information. So in your study, this would be something like the learning mechanisms know to look for animacy. Okay. And while there's certainly evidence that humans are biased towards animacy information, it implies a very specific learning mechanism looking for very specific kind of information. In instance-based models, what happens is when participants do a study like yours is they essentially are passively encoding all of the trials, right? Imperfectly. They're not have perfect memory for these things, but they're passively encoding these things. Then when you get to the test trials or a subsequent trial, if you don't really have a test phase, what happens is they go to retrieve similar memories to the one that they're encountering at the moment, and that guides their behavior. That retrieval process might result in a conscious, explicit representation, or it might result in implicit representation. And if you take that sort of approach, at least in my own head, it made a lot more sense of your data, because then your results are to do with varying degrees of awareness within a single memory system rather than different kinds of learning mechanisms. If that intrigues or interests you at all, I will forward you things to read. Lots of cool stuff done with like distributional semantic models and things like that. And if that's helpful in any way, and I think it could be with some reanalyses of your data, awesome. I'll be happy to assist and give you some guidance. And if not, you can ignore everything I just said, and that's okay too. So I just wanted to make you aware of that though, because it's a really cool thing that I think could help you. My one last question that I really wanted to ask, and I asked this of all dissertation defense students, of all of the results in your dissertation, and there's a lot of them, which one do you have the least faith in and why?
Which one are the least faith in? Yeah, there is really a lot of them, so we're putting me in the spot. I think there's one that I kind of have least faith in, not because of what this one shows, but the fact that I tried it in other places and the results aren't always so clean. So one of the analyses that I do, or that I show in the dissertation, is the drift diffusion modeling, which I didn't really touch on here. Actually, I think I have a schema or something, or an image that shows it. But I will say that actually, back in 2019, we've been piloting the experiment all sorts of ways. Let's see, I think I can pull up the diagram for it. Changing the words that are used, when things are shown, changing various, trying to calibrate everything behaviorally before we got to the actual EEG nature of it. And in some of the data that we collected, we found these very beautiful results that showed this very nice and clean storyline about one component of an evidence accumulation process being altered differently than another one in implicit versus explicit learning. And in my behavioral piloting data, we got these very nice effects where you can like boil down the results to a couple of sentences. But I think I tried this also on the different data that we have that failed with like word timing and stuff like that. And the results aren't always so clean and clear. So what I'm trying to say is that actually, it's not that I don't think that these results are themselves valid, but that I think that to get the models to plot a significant difference in the different conditions relies on so much, I don't want to say luck per se, but it's so subject to the idiosyncratic aspects of things like word timing and stimulus timing and all that, we'll find that this kind of thing, this clean storyline doesn't always replicate. And so, yes, and I think that takes me back to when I learned as a PhD student that, it's a big disillusionment or disappointment when you go from your stats classes where the data are all like fake and generated and show beautiful effects to the real world where it's always extremely messy, there's artifacts in EEG trials, et cetera.
Sure, that makes perfect sense. All right, thank you very much, David. I'll turn it over to whoever's next.
Thank you, Philip, for the question. That's a great question. I learned a lot. I just learned something new from David in his response. I've heard a lot of the other stuff before. Okay, Jen, we'll turn it over to you since you are internal but not here. Physically external to us.
Hello, thank you, David. Yeah, I, just to echo everyone else, really enjoyed reading this. Your explanations of things are super clear. I feel like I actually, have a pretty good handle on at least the concepts behind MVPA. I really like the idea of being able to adjudicate between domain general linguistic learning. I mean, that's the tradition I come from, right? This whole idea of, what is domain general, what is specific to, a language module. So I think this idea of being able to separate quantification of these indices for implicit and explicit processing, just already thinking of lots of applications of that just in my own work that I'm affiliated with. So most of my questions have come up in some form or another, including my time machine question that Laura brought up. It was the same thing. If you could go back and choose a different paradigm or choose a different property perhaps to look at. And so maybe I'll just build on that one a little bit. And so again, this is more of an open-ended, just thinking question, but maybe instead of thinking about, what paradigm or what property might you observe here, do you see a way of applying this to an actual like real world L2 acquisition scenario where you would work with L2 learners and how you would envision being able to carry out a study like that? Where would you want them to be in the learning process? And again, you don't have to have all the answers to this. I just want to know, is this something?
Yes, there's thanks for the question.
Logical validity and such.
Right.
Stop sharing your screen.
Oh,
Thanks. So we can.
so in terms of applying this sort of more outside the laboratory, I've given a presentation here in between the interdepartmental conference that was specifically about how these kinds of results can be applied to second language pedagogy and acquisition. And as you'll see in the dissertation, one kind of major theme is that this experiment and then also previous paradigms or previous experiments that have used the same paradigm kind of all have this possible critique that because there's this contingency between the button pressing response and the stimuli that you're shown that is possibly more low level than actually think about linguistic concepts, that this contingency or the fact that you can learn things in the experiments that get you through the task and get you to do the task well, but aren't necessarily the targets of learning. That I think is one of the biggest takeaways that I had from the dissertation. So for instance, one, the fact that like I present in a lot of the additional analyses, the fact that you can do the task pretty well without really interacting with noun semantics, and then also how the drift diffusion modeling sheds additional light on how you can like learn things that have nothing to do at all with your purported source of like linguistic evidence in the speech stream. That how I translated that finding to L2 pedagogy is to say that whenever there's L2 tasks that are being designed, we need to be extremely careful to make sure that overall the practice that the learners do, we need to be aware that they might be latching on to contingencies in the language data that they get that aren't actually the contingencies we want them to learn. I'll give you kind of an easy or like a straightforward example is that in the Roman, in Spanish and Portuguese too, and Italian and so forth, you have nouns that end in either O or A, and if they're O, they're usually masculine, and if they're A, they're usually feminine. You can imagine somebody trying to teach or practice this distinction, but when they, even something as simple as the way that the exercise is formatted on the paper, the participant or the learner can go through it and just seeing the O's and circling M for masculine and seeing the A's and circling F for feminine and having to do this low level contingency where the learner is just learning to like go through the task and like, I don't want to say cheat, but hack the task as much as possible to get them through it without any actual like generalizable knowledge that interacts with noun reading. I mean, I know that the O and the A kind of system statistic is something like important that you learn in learning Romance languages, but what I'm trying to say is that like when you look at the micro dynamics of the actual task, you need to make sure that it really pushes learners to engage with meaning to make sure that these low level tricks aren't the case. Like you could have somebody that doesn't really, for example, read Western characters. And if you show them the task with O and A and masculine and feminine, you could just teach them to tell apart the distinction. They could like go through circling things without knowing at all what the noun has to do with it. And so, for instance, another example of this, possibly not from my experiment, is I remember somebody telling me about the Duolingo app and that there was a certain exercise that they weren't very satisfied with because they felt like they were just learning to press either the left or the right side of the smartphone screen and like in such a way that it didn't actually make them think about the noun in isolation of the way that it's actually manifested in real life. Now this, what I'm getting at is actually kind of tricky because I'll tell you one anecdote. In the version of the experiment that I piloted where the responses are randomized on each screen or on each trial, what I found that happened when I was like trying it out on myself is that I could kind of hack my knowledge of the rule even though I could control for the motor compound. What I mean to say is, instead of actually thinking about living things and non-living things, it got to the point where I was looking for the little box that starts with the letter A for inanimate and the little box that starts with the letter I for inanimate, because I became so, as they say in cognitive neuroscience, overtrained to the specific aspects of the task. So the sort of takeaway that I would have, which is an important critique of previous studies that have used this artificial language paradigm, but also looking forward to how to actually implement it in the classroom, is to say that you need to make sure to design your tasks in such a way that it engages meaning and that those low level kinds of hacking kinds of work. Beautiful example of this is from Kara's previous student, Brianna Villegas, who was doing some research related to low band patterns. What do they call it? Where you like
Processing instructions.
Yes, thank you. Processing instruction, where like you set up these experimental tests in a very clever way, so that whether or not they like learn the grammar actually affects how they like interpret a scene or something like that. And so for instance, for any like Spanish 101 or 102 teachers, one thing I like to do is a very simple exercise where, okay, I shouldn't go into it for running out of time.
I actually want to add to this question though, because we've also had a conversation kind of at the reverse where you had this idea like maybe you can actually leverage that hacking, like if they're making some contingency, even if it were to be at least somewhat non-linguistic, that might actually boost kind of learning the linguistic contingencies as well. So kind of the opposite of what you're saying, but that's another thing that David has talked about in conversations.
Can I add a follow-up thought that also touches on what Philip said about
Yeah.
the instance-based learning? So in the previous domain general cognitive psychology literature, they talk about how one possible way that explicit processes can interact with implicit processes doesn't actually have to do with the neural substrates of how the learning actually occurs, but just the fact that if you take one strategy, you'll get more input. And then that input feeds whatever isomorphic learning mechanism goes on. So there's to say, it's not that there's qualitative differences in the kind of learning that goes on, but the strategies that you use can actually just help you navigate your world as an L2 speaker. Even if the strategy itself isn't the best way to make those neural connections happening, to the extent that, for instance, hacking that kind of task can like get a learner sort of through a task, give them some exposure, have them do better on the grade, and then slowly over time, as they're successfully not failing their Spanish class, they get a lot of exposure. It might turn out that, like, you see what I'm trying to say, that like even if the approach itself isn't the neural sort of substrate of it, then it can help you actually quite a bit. It's kind of like, think about how crutches aren't supposed to simulate bipedal motion with two legs, but it sort of like does the job. So in that sense, you can think about those little hacks as tricks that you can leverage.
Potentially, yeah.
Yeah, I think one of like the kind of side parts to this question is artificial language the best way to look at this if we want to avoid, if we really want to be making sure that they are accessing meaning and features and all of this stuff rather than looking for patterns, right? So, because I think about this quite a bit. Dave Miller might have told you about the study that he's on that was looking at L3 initial stages, does a learner rely on their L1 or their L2? And they used a mini artificial grammar as well. And what they found also was a P300. It was essentially, attentional stuff that was not linguistic. And so it's kind of getting us to the point where we're talking about like, should we be using artificial grammar to look at these things? Or, and again, I'm not somebody who is an expert in this, so this is sort of a naive question.
I think one important kind of like anecdote that I might bring up here that's related to is, I happen to have heard that some biologists, when you do research on the human pancreas, they find that its behavior, when you look at it under the microscope, is actually different than its behavior somehow when it's actually within the human body. So I think that one thing that I like to point out that it's very dangerous with these artificial language paradigms is that, for instance, here, this is a semi-artificial language paradigm that we use. It means it's just 4 words, but you combine it with English nouns. By contrast, in a real L2 scenario, even just the noun learning could be your bigger bottleneck. So Holger Hopp talks about the bottleneck hypothesis. What if actually the real bottleneck to making good L2 learning happening isn't so much about the nitty-gritty of the grammar, but maybe we're overlooking here how even just those lexical barriers can sort of get in your way. So seen from that view, I think a semi-artificial language learning paradigm, you always are going to be bugged with this thorn in your side, this caveat that it actually doesn't, like, even the advantages of an artificial language, you don't even get those full advantages to the extent that you're like grafting English nouns that you can already process really quickly into this sort of context. So just sort of pointing out how the semi-artificial, like, we shouldn't overlook the fact that even if you're learning pro canto and all the words are made up, then the fact that it's a fully artificial language might sort of better replicate the timing and difficulty of relative concurrent parallel processes when you're also trying to learn the nouns in addition to the grammar. So it's an extra kind of issue for ecological validity. I think what's exciting now is a lot of folks are turning towards more naturalistic methods in second language learning research. So that's what I'd be excited to be working on as a postdoc in Michigan, actually working with naturalistic language that even though the artificial language stuff can make you see very specifically how something works in a very carefully controlled context, it's absolutely essential to get into this, that we also have to balance this sort of laboratory-based tradition in science with the ecological lab tradition. So I could go on for ages about that.
If we had more time, I'd also like to hear a little bit. I think this is, an incredible discussion that is important to the field. And there's, I'm not going to ask you to do this right now, David, but the reasons why we think there might be ecological validity to this to artificial grammar paradigm. So, for example, There's a huge debate about whether the P6 is actually the P3. So in that case, if you find a P3, it doesn't necessarily mean that that there's not something, non-linguistic going on there. So that might be something to think about, or that we might even need to boost up, or even a discussion. I don't know, we'll talk to the committee about, reasons for and reasons against for ecological validity. So you just talked about reasons against, but I do think there are reasons for that we need to make sure that we acknowledge as well. I mean, in the end, that's the paradigm that you decided to use.
Just a quick thought that if and when we use these kind of artificial language paradigms, I think what we should always be conscious of is what they call the pragmatics of the experiment. So for instance, some participants have had more exposure to the concept of going to a lab and doing an experiment for a researcher and navigating the weird sort of power dynamics and so forth that emerge versus other participants who maybe haven't had like that kind of exposure. So
Yeah.
what I mean to say is that one thing that would be helpful is to at least make sure that even simple little things like making sure a participant is comfortable, that they kind of get a sense of what the research is, to know that they're not being tested, all that kind of thing would help to reduce potential variability between participants when some of them feel like they're being tested and then other folks go in and they kind of know it. And they can also sort of work against the researchers sometimes, because if participants have done a lot of previous experiments, and they're primed to know that there's going to be some manipulation, then they could also be there very much on their toes doing hypothesis searches and so forth. So that's one thing to be conscious of about controlling.
I have one other question, but it's not a big one, and I know it's already 6:25. So if you wanna, I can just send it to Debbie separately.
I think if we have time, and then we'll, because I was thinking we'd go to the committee at 10, 12, 11:30, but that gave us some buffer time. So yeah, if you want to do one more question, then we'll hand it over. Is that good for you? Or are you ready to go, Kim?
If you wanted to go at 11:30, that's 4 minutes from now.
Yeah, no, I was saying we have buffer time. We can push that back.
No worries.
Yeah, I'm good with pushing that back. Yeah, go ahead, Jim.
Oh, yeah, okay, so my other question is, and I mean, you addressed this very extensively about the idea of not wanting to exclude participants based on their knowledge of another language. And I think, for sample size and everything else, I mean, you did an amazing job, and we have, it's all about trade-offs, right? I'm just interested because I was reading the debriefing comments, and also just like another plug for always give debriefing questionnaires. They are so informative. So seeing ones like the one that referenced like Spanish gender, for example, like, oh, I noticed just kind of like how Spanish has gender. This is something that a learner wouldn't pick up in a study like this if they'd never had exposure to another language, right? And so there really is something to think about here. So I'm thinking, like, what do you think the role of other language study play here? Do you think if you were to do this again, would you control for language differently in future research? I know you brought up this idea of like maybe the salience of this feature of animacy is different depending on what language someone's had contact with. And you brought up the fact that a lot of them were heritage speakers. Now, I don't think that this is necessarily a problem because heritage speakers are not that sensitive to differential object marking. So I don't think that's a problem, but there could be other scenarios in which this could be of interest. So kind of how would you address this in a
One
follow-up?
that comes to mind immediately is the fact that it's almost as if they're two separate dimensions. One is meta-linguistic exposure, and then the other one would be just previous language experience sort of overall. So you point out that, for instance, Spanish heritage speakers aren't so sensitive to differential object marking with A, and oftentimes it's, it can be the case, for example, it can be the case that it's only when they're actually in a second language classroom that they pick up on all those kinds of words for verb conjugations, or even the word like animacy, animate, inanimate. Those are really concepts that people use in linguistics and maybe in meta-linguistic explanations that people don't think about so much. Or they categorize as living, non-living, but they don't think about how it has an effect on language. So for instance, even in English, they say that animacy plays a role, whether you use a dative with apostrophe S or whether you use a dative with the preposition of. And that's something that it's like, oh, great, now that I've been exposed to it, I can really think about it a lot and I'll be on the lookout for another languages and so forth. But that's very different from having the actual language proficiency. Having just taught a mixed classroom for advanced Spanish grammar, along with Kim and Jen, yeah, y'all two also taught with me. And seeing how there's sometimes how sometimes you can see the difference between, for instance, the L2 speaker who has been exposed to metalinguistic textbook explanations and how sometimes they can be more adept at picking up on this kind of metalinguistic thing than somebody who starts sort of sorting out these concepts for the first time if they haven't really thought about the difference between indicative or subjunctive or something like that. Now, in terms of this study, in terms of the relevance of this sort of discussion to my study, because UIC is like 89 or 90% self-reported multilinguals, then it'd be very, very, very tough to control for it just by choosing self-reported monolinguals. I think what's a better thing to do, in my opinion, is to just collect all the data, collect it very quickly, right? And then afterwards you can go back and chop up the data and look at participants based on different sorts of criteria. And then that way you can have a sort of I think scientifically the best approach is that, for instance, a conservative criteria for saying, okay, let's get the most monolingual folks as possible, and then more loose criteria, and then that way you can see whether or not it even makes a difference in the first place. Because it's very important to keep in mind prior language experience always, yes. But it's helpful. Like for instance, when we talk about power analyses, or in other contexts, when we talk about the coding for aware versus unaware participants, when approaching this kind of issue tangibly, the actual experiment design and the analysis, I think running several analyses with different thresholds can itself shed some light, rather than just thinking about controlling for multilingualism as a potential experimental problem to look out for. And there's just to plug too that Sarah Hassan, who was on the picture there with the acknowledgements, she did her undergraduate capstone specifically on this issue of prior L2 and multilingual experience, and there was we really sort of ran into this issue of well, how do you even quantify something like that? It's not is it how good you are in the other languages? Is it how many other languages you speak, which can lead to sort of redundancies for languages related? Or maybe it's something, they say things like Noam Chomsky is self-described monolingual, and he's been very influential for the field, but it kind of shows you how there's this disconnect between thinking about metalinguistic things and how you might apply them in experimental context versus prior language experience. I kind of went on for a long time, sorry.
Okay, yeah, now we have Kim. I still want to end, we'll end this at noon in half an hour, but we have time for plenty of time for questions with Kim and then the committee discussion after that.
So was this purposeful? The heritage speaker phrase came up you just threw it up so that I could knock it out and make a connection.
Well, that was
Totally, I feel like this was orchestrated. But before I move into my comments, I want to say that your response to the other thing about the pancreas behaving differently when it's observed and when it's not observed. All I could think in my head was that Schrodinger's pancreas would be a great band name, right? Schrodinger's pancreas. Anyway, so I wanted to say, first of all, congratulations on doing this work. I know you had some curveballs thrown at you because of COVID, and yet you persisted. That couldn't have been very easy. Dissertations are hard enough without pandemics. So congratulations to you on that. And then echo what everybody else said about your use of personable language. Examples, clarity of expression, analogies, fantastic. You make this highly readable. And so that's just a great gift that you have, even in your presentation and your discussion of things like crutches and pancreases and whatever, it all kind of makes sense to regular folks. And as highfalutin and challenging and complex as our ideas can be sometimes, when you can translate them to people who aren't as immersed in it, that's just such a gift, and it shows that you really know your stuff. So congratulations to that. So I've got 3 questions, and if it's okay, what I'd like to do is say them all because I think they're all related, but also I'm afraid that if we pause and get an answer to one, I won't get to ask the other 2. So I'm going to say all 3, and I hope not to be too long-winded about it. And then when I'm done, I'll say, so in summary, it's blah, 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 and I'll have one word that'll remind you of each one. And if you don't get to all of them, it's fine. We can chat about it later because I'd love to pick your brain because I really do want to know what you think. Okay, so the first one, when we say things like, and I'm quoting from your dissertation, models of attention and awareness in the field of second language acquisition disagree as to whether implicit learning, i.e. the acquisition of implicit knowledge through implicit processes, is possible. Isn't this how kids learn languages, right? Is it worthwhile to specify that you were saying among adults? I don't know, that's my first question, and this is connected to the second. In what ways do you think bilinguals, either heritage speakers or what we might call societal bilinguals, right? Here I'm thinking about Spanish Quechua bilinguals in Peru, or Catalan Castellano bilinguals in Catalonia, right? In what ways do you think their performance might have differed? That I'm sure you could talk about for ages, but maybe you could just sum it up for us real quick. And which is related to what you just said about, getting stay bilinguals of different languages, right, to participate in this. And then finally, it's perfectly defensible, I think, for you to state that you use synonymously the terms learning and development. Perfectly, no issue with that. I don't think anybody does. This is sort of a personal / professional question for me. I wonder about the use of the word learning with heritage speakers, right? Because we talk about teaching them Spanish. No, they know Spanish. They're learning Spanish. Well, they already had Spanish. And I get a broader meaning of learn is, I suppose, to add new things to what you have, but I don't know why I find that kind of gets me a little something. It maybe development is more accurate when we're talking about heritage speakers. Anyway, what might be, here's the real question. I guess I'm sneaking two questions into one. So the use of the terms learning and development heritage speakers, and then what might be some applications or implications of what you have found here for heritage speaker teaching? And I'm asking this specifically related to morphosyntax. So for example, as you know, in the heritage language program, we try to work with getting them to use the infinitive instead of the gerund in subject position, for example, or the subjunctive instead of the indicative, right? Or are putting prepositions in normative locations. As la persona que hable con, try to get them to say es la persona con la que hable, right? So I sort of wonder to what extent grammatical development is similar and different between L2 and heritage, right? And this is the paper I did with Kara, right? We looked at processing instruction with heritage speakers and L2 learners, and we found some interesting differences. So that was a lot of stuff there. I suppose he probably has, about 5 minutes to play with these thoughts, and I'll repeat what they were, okay? Kids versus adults, bilinguals versus monolinguals, learning versus development, and possible implications for teaching, quote unquote, teaching grammar, I guess, to heritage speakers.
Okay, so to sort of touch on those points, I'll try to keep them all kind of brief. My responses. I should say, first of all, as the babies who seem to learn language fully implicitly, then you can really get into the weeds about what you might consider the difference between implicit and explicit. Of course, whenever it's framed in research questions and prior research, and whenever you have to have different conditions that you compare against each other in inferential statistical tests, you always can really only work with one exemplar of the other. But bear in mind, like I mentioned in the literature review, that explicit processing can involve things just as low level as noticing, orienting. Leal has this lovely model that looks like an onion with the different layers about how there's a lot, there's this very fuzzy threshold defining what consciousness is. Even words like grammatical rule or pattern or stuff like that can actually oftentimes presuppose a lot of meta-linguistic idea of how language works. So for instance, in the interview that we give them, I think we, whether we ask them, did you notice a rule versus do you notice a pattern versus, oh, there was a rule or there was a pattern, or those sorts of words are human constructs from this globalized society that has industrialized education where knowledge comes in textbooks and you get checked off on your knowledge of it. So we need to be very, very careful. I think talking about implicit and explicit, that helps more scientific tools to facilitate the conversation. Whereas, for instance, a baby, you could argue if their consciousness change, or if an EEG analysis of their brain oscillations showed some difference in arousal or attention states whenever something exciting happens, whenever they learn language, you could almost argue that that's some kind of explicit processing. Does that make sense? So here, maybe I'm pushing it here, but for instance, say that you go to a child or a baby with a particularly effusive and gregarious and smiling approach. The fact that you got their attention so much and makes these neurochemicals be released and make it easier for them to form a strong memory. That has some element of explicitness to it, to the extent that somebody's. You see what I'm trying to say? So I would say that when I talk about fully implicit learning there, I could go into this long caveat. There's this lovely book by okay, I'm going on too long. Let me move on sort of to the next one. Talking about heritage speakers and bilinguals, One of the questions, I think the last one that you mentioned was how this might be applied to the language classroom. For having taught HOP and having taught advanced Spanish with a lot of heritage students, I think one thing that I really like to point out is that the quote unquote experimental pragmatics, or the feeling about whether there's a rule or something like that, can be a lot more impactful for heritage speakers than for L2 learners. I'm not making any claims about like brains or neurobiology or critical stages or anything like that. All I'm saying is that when a heritage language becomes such a personal thing to somebody, even if we found a reaction time effect and explicit learning was better in this paradigm or something like that, you would always want to temper your focus on the quote unquote most like effective method or something like that, versus more of these like soft skills things, like making sure that people are comfortable in the classroom, like making sure that people are like that kind of thing. And I'll give you a kind of tangible example of that. I was just in Texas visiting my family. My little brother is a heritage speaker, a very late heritage speaker, if you could call him that in a sense. Intentionally, I don't correct him whenever he says something quote unquote the non-standard, because I know that even if correcting somebody might help their specific learning of that item, the overall effect it would have on their overall like mood and production and so forth would be like shooting oneself in the foot. So we need to understand that always there's this like second conversation that has to happen, not just as an afterthought, but almost sometimes as a priority as to whether you're going to get more effective ultimate outcomes by having somebody have a lot of input and produce a lot and being comfortable in a certain context, versus these kinds of ideas like rules and patterns and so forth that can have these power dynamics, like power dynamics, and the DCM said that kind of like a human construct involved in it. You also talk about learning versus development. Actually, I would agree with you entirely. I would say, sorry, let me slow down. I would agree with you, or let me sort of like the way that I view sort of learning, development, knowledge processing, etc., is that sometimes you can have mechanisms that are sort of one and the same thing. So, for example, imagine these Hegelian learning models where synapses fire whenever some kind of processing happens, and some change in ambient resting state connections between the cells is like slightly changed in one direction or another because of that firing. Here, you could say that processing happened and knowledge, quote unquote, was gained to the extent that this cellular connection was changed slightly, etc. So development, knowledge, learning, etc. Terms like that, you might be sort of hovering over this one actual phenomenon as it's manifested in the real world. In the dissertation in chapter 1, I have a section where I talked about these definitions for knowledge versus processing, this and that, and so forth. Kara was very helpful in guiding me through making sure that I use my terms consistently and carefully and so forth. Because I think that like when I came in, if I come in with a sort of heavy learning perspective, then that can push me towards thinking, who cares what terms you use? It's like one and the same thing. Versus we need to stop and slow down and also think about how these terms, no matter what you think about neurobiology or whether it's generative versus usage-based grammar or anything like that, terms like knowledge and learning and development and so forth can also have this kind of valence to them, in that like development is good, learning is good, but like you think of learning as somebody sitting in their classroom rather than if they're just practicing the same old grammar structures and now with their abuelita in the kitchen, then that's like a learning of itself too, to the extent that those linguistic connections are being strengthened. And
so maybe is that sufficient for now?
Yes, I'll take David out for coffee one day and we'll talk more about this.
Well, we'd love to do a lunch afterwards, so if you have time, I know you just got back from Italy, but yeah, we can continue conversations. Okay, so thank you for fantastic and challenging questions, but that's exactly what science needs. So we're now in the phase where we will ask David and Alexis to leave the room. David, can you make me a host?
yes.
You can have